All right, hi folks, this is Larry Mussolino. I'm recording a video for MATH022. I want to go over a few topics in Objective 6, and Objective 6 introduces this idea of graphing. So we want to be able to graph points, and then we're going to be also graphing lines. So let's get started with working with points. So in this example, they're going to ask us to locate these different dots or points on this map. So when you look at these points, the way to think about these is imagine starting here at this location. I'm marking X. Ask yourself, what horizontal distance would you travel? And then what vertical distance would you travel to arrive at that blue dot labeled Berlin? Notice it says, give the location of Berlin as an ordered pair, X comma Y. What that means when they put X comma Y, they're really asking you, what is the horizontal distance to travel to get to that point? And then what is the vertical distance to travel to get to that point, starting from this X? By the way, we call this X the origin. So the origin is always the starting point when we're graphing these locations. All right, well, I'm noticing that horizontally, I would be going over to 7, distance of 7. So that's going to be the X value. And then vertically, it looks like I'm going up a distance of 9. So that would be the Y value. So Berlin is located at 7, 9. All right, so again, it's always going to be the horizontal distance comes first, comma, the vertical distance comes second. We call this an ordered pair. All right, well, there's another topic that asks you to plot a point yourself. So let's take a look at this one. This is plot the point 4, 5. Now in Alex, Alex is going to give you this coordinate, this map, where X is the horizontal axis and Y is the vertical. So remember, the first number is always the horizontal distance to go. And the second number is always the vertical distance. So what this is asking me to do is start here at the origin, go horizontally 4, 1, 2, 3, 4, and then go vertically 5, 1, 2, 3, 4, 5. So I'm going to start at that X, go horizontally 4, then vertically 5, and place a dot at that location. So this green dot is the point 4, 5. We're going to be using this as we start graphing equations. So what we're going to be doing in a little bit is actually ending up graphing 2 points. Let's say there's a point here and a point there, and then connecting these 2 points with a straight line. All right, we'll get to that in a minute. How about, let's do the table for a linear equation. All right, they're asking me to fill in this table. Well, they're giving me an equation here that relates X and Y together. So notice it says Y equals 3X plus 4. So what they're asking me to do here is for each line in this table, take the X value here, it's going to be -6, and plug it into this equation. So I'm going to replace this X with -6. Now I'm just going to work this out using order of operations. Remember, order of operations says do multiplications first before additions. So this is going to be -18 plus 4. That means Y is -14. So that's the answer to put right here, -14. All right, let me do another example. How about when X is 0? Well, I'll go back to the same equation, but now I'm going to replace X with the number 0. But 3 times 0 is just 0, and 0 plus 4 is 4. So this answer here is going to be a 4. All right, so all they're asking you to do here in this example is take each X value that they give you, substitute that X value in the equation, figure out the corresponding Y value, and put that number in this second column. All right, let's do, how about graphing an equation? Let's take a look here at graphing an equation. All right, so it says here, graph this line, Y plus 3X equals -2. Now, it turns out there's a few ways to do this graphing. Let me give you a couple of options. Option A is to make up a table like we just did in the previous example. Option B is going to be to use something called use a slope-intercept form of a line. I'll show you that in another example. And another option is to use x and y intercepts. I'll show you that in another example. So why don't we make a table up here for this one? Now, all I have to do is make a table just like we did in the previous example. And what I could do is pick any values I want for x. It's totally up to me. So I'm going to pick x to be nice, easy numbers to work with. I'm going to pick x to be 0 and 1. You can pick x to be different values. You could pick x to be 2 and 5. You could pick x to be -3 and 7. It's totally up to you. The reason I'm picking 0 and 1 is these are the numbers that are nice and easy to work with. All right, now I want to figure out the corresponding y values that go here. Now, one thing I could do to make this a little easier is to get y by itself on one side of the equation. So I'm going to subtract 3x from both sides of the equation in order to get y by itself. So that's going to make it y equals -3x minus 2. Okay. Actually, let me write it as -2 minus 3x to make it a little clear what I'm doing there. So this was -2 subtract 3x. All right. Now let me take each x value and plug into this equation. So I'm going to take x equals 0. Well, if x equals 0, then y is -2 minus 3 times 0. But 3 times 0 is 0. So this is -2 subtract 0, but that's just -2. So we just figured out this y value is -2. All right, let me do the same thing, but now x is equal to 1. We get a little more room here, so I'm going to use x equal 1. All right, so that means y equals -2 minus 3 times 1. So this is going to be -2 subtract 3, which is -5. So this y value is -5. All right, well, now that I have this entered into a table, I can write this in like an x comma y format if I want. 0, -2 for the first row and 1, -5 for the second row. Now I'm going to go ahead and graph. Remember the way you plot these xy points, the x number is the horizontal distance, the y number is the vertical distance. All right, so let me take this first one, 0, -2. This says go horizontally 0 and then go vertically -2. So I'm going to start here. I'm going to go horizontally 0, which means go horizontally nowhere, but then I'm going to go vertically 2. That means go down 2. So here is that point 0, -2. All right, let me do the same thing for 1, 5. 1, -5. 1 is the horizontal distance and -5 is the vertical. All right, so I'm going to go horizontally 1 and then vertically -5, which is down here somewhere. That's going to give me this dot down here. So this dot is 1, -5. When they say graph the line, they're really asking me to connect these two points with a straight line. So here, that blue line is the line they're asking me to graph. Okay, and you'll see when you go to do this in Alex, it'll give you a an XY coordinate system, and it'll give you a way to actually graph the lines. You plot the 2 points and then connect the 2 points with a straight line. All right, well, let's do a couple of other graphing. How about here, graphing a horizontal or vertical line? All right, well, let me give you a little background on this. When you're graphing lines, the example we just did was a line that went downhill like this. That was the example we just did a second ago. But you could have a horizontal line. A horizontal line always has the equation y equals a number. A vertical line, so this is a horizontal line, it's always going to be y equals a number. A vertical line is going to have an equation. I'll draw it here. Let's say x equals -2. A vertical line is always going to be the form x equals a number. So when I look at this example, I'm seeing it's y equals a number. So I know our graph is a horizontal line. One way I can graph this is make up the same XY table as we did a few minutes ago. I'm going to pick X to be any numbers I want, totally up to me. I'm going to pick 2 and 5. You could pick different X values. Normally, you would plug these X values in the equation and solve for Y. But the equation here is a little bit different. It's just Y equals -1. What that's telling me is the Y value must be -1. So I'm going to put -1 in for Y. All right, well, now these XY points look like 2, -1 for the first row and 5, -1 for the second row. All right, well, I'm going to go plot those. All right, let's do 2, -1. I start here at the origin. I go horizontally 2 and vertically -1. So that puts the dot right there. Let me go to 5, -1. I go horizontally 5 and vertically -1. That puts the red dot right there. Well, notice when I connect these 2 points with a straight line, it's a horizontal line. Okay, so anytime you see an equation of just y equals a number, the graph is going to be a horizontal line. All right. How about if we go here, find the x-intercepts and y-intercepts of a line. All right, well, what this is really asking you to do is imagine we had a line that did something like this, let's say. And here's the x-axis, here's the y-axis. What they're asking me to find is this point right here where the graph crosses or intercepts the x-axis. This is called the x-intercept. I'll just make something up. What if this was at 5? This x-intercept would be 5, 0. This point here on the y-axis, where the graph crosses the y-axis, that's called the y-intercept. And maybe this is at a height of 4. So this point would be 0, 4. All right, well, here's an easy way to find x and y intercepts. To find the x-intercept for an equation, you let the other letter equal 0. So I'm going to let y equal 0 in the equation. All right, so I'm going to do it. It's going to be 2x plus y equals 0, but we're letting y, equals 6. We're letting y equal 0. So that's going to be 2x plus 0 equals 6. That's 2x equals 6. Divide both sides by 2, x equals 3. So the x-intercept here is 3, 0, because the x value is 3, the y value is 0. If I wanted to write that in XY format, I would write it as 3, 0. The graph is crossing the x-axis at 3. All right, let's find the y-intercept. Well, to find the y-intercept, you let x equals 0. So I'm letting the other letter equal 0. All right, well, that means 2x plus y equals 6, but we're letting x be 0. That's 0 plus y equals 6. That's y equals 6. So we have x is 0 and y is 6. 0, 6 is the y-intercept. So in our example, I guess I'll make this our example. This was 0, 6. So this point was a 6 up here. And 3, 0 for our example. That means this point here was a 3. And this is another way you can graph a line, because if you can find these 2 points, the x-intercept and the y-intercept, you can connect those 2 points with a straight line. That would give you the graph you're interested in. In fact, why don't we go and do that? Let's do this example here. It says graph a line by first finding the x-intercept and y-intercept. All right, well, let's do it. So let's find the x-intercept first. Well, to find the x-intercept, you let y equal 0. So let's take this equation, 6x plus 9y equals 27. But I'm going to let y equals 0. That's going to be 6x plus 9 times 0 equals 27. That means 6x equals 27. Divide both sides by 6. X equals 27 divided by 6. Now, that's not a whole number, but that's okay. Alex is going to give you a way to graph this. This equals 4.5. So the x-intercept we just found is 4.5 comma 0. All right, let's find the y-intercept. To find the y-intercept, you let x equal 0. All right, I'm going to go back to that equation and replace x with 0. But of course, 6 times 0 is just 0. And 0 plus 9y is just 9y. Divide both sides by 9. I'm getting that y equals 3. So x equals 0, y equals 3. The y-intercept is 0, 3. Well, I can go graph this. If I had a graph here, 4.5 comma 0 means go horizontally 4.5. 1, 2, 3, 4, 5. So 4.5 comma 0 would be right here in between 4 and 5. And then 0 comma 3 means go up 3 here. So here's the y-intercept. And then I'm just going to connect these 2 points with a straight line. That's the graph I'm interested in. All right, let me do one more example maybe on graphing. Whoops, I'm going to objective 6. How about if we want to graph a line in this kind of format? All right, well, this is yet another method to graph. It's called slope-intercept form. All right, well, the way this works is you compare the given equation to y equals mx plus b. When you do that, this m value is going to be the slope of the line. I'll explain that in a second. And this b value is going to be the y-intercept of the line. All right, now let's do that for our example. Our example, let me write y equals mx plus b here. And directly below it, I'm going to write y equals 1/5 x minus 3. Now I'm just going to kind of do a match up. Notice m is whatever number's in front of x. In our example, m is 1/5. We call this the slope of the line. So m is the slope. Our b value, which is the y-intercept, is -3. So this is the y-intercept, and this is the slope. All right, now here's what we do. We go to the graph, and I can plot the y-intercept because I know the y-intercept is where the graph crosses the y-axis, but our y-intercept is -3. So I'm going to come here, -1, -2, -3 on the y-axis, and I'm going to put a dot. That's the y-intercept. All right, now I'm going to use a slope because I need a second point. The slope is going to give me the second point. What I do with the slope is I think of this as the change in the vertical on top and the change in the horizontal on the bottom. So the top number is telling me the vertical distance to go. The bottom number is telling me the horizontal distance. So really what this is telling me is this 1 on top means go up 1, and the 5 on the bottom means go over to the right 5. So I'm going to do that. I'm going to start at the y-intercept. I'm going to go up 1. So here I just went up 1, and I have to go over to the right 5. 1, 2, 3, 4, 5. So now I'm going over to the right 5, and I'm putting another dot right there. I connect these 2 dots. This is the line I'm interested in. Okay, so to summarize, what we did here is we took the equation they gave us and we compared it to this form. This is called the slope-intercept form of a line. You write it as y equals mx plus b. If you forget this, it's in the reference packet. When you compare the given equation to y equal mx plus b, you'll be able to figure out b, in our example is -3. You'll be able to match up m, in our example is 1/5. Well, b is the y-intercept, so you can immediately go put a dot on the y-axis at -3. Then the slope tells you the vertical distance and the horizontal distance to move from that y-intercept. So this one is telling us go up 1, and over to the right 5. All right. All right, folks, hope this is helpful as you're getting started here in Objective 6.